input, there is only one output. So how about the relation? Relation is all set of inputs and outputs. So just remember, all functions are relation, but not all relations are functions. So here are mappings of functions. The domain is the input or the x value, and the range is the output or the y value. Each x value is related to only one y value. Although the inputs equal to -1 and 1 have the same output, this relation is still a function because each input has just one output. This mapping is not a function. The output for -2 has more than one output. For example, f of x is equal to 2x plus 1 is to x is equal to 2. So the x is equal to 2 is our x. So all the x will change into 2. So f of x is equal to 2 times 2 plus 1 is equal to 5. So that's the answer. So let's try another example. F of x is equal to x squared plus 2x plus 1 is to x is equal to 3. So let's change the x into 3. So f of x is equal to 3 squared plus 2 times 3 plus 1. So 3 squared is equal to 9 and 2 times 3 is equal to 6 plus 1. So it's 9 plus 6 plus 1. So f of x is equal to 16. So that's the answer. So next is the composition of function. For example, f of x is equal to 2x plus 1 is to g of x is equal to x minus 2 is to h of x is equal to x squared plus 2x plus 1. So f of times x is equal to f of x is equal to 2x plus 1 is to x is equal to 2x plus 1, then 2 times 2x plus 1 plus 1 is equal to 4x plus 2 plus 1. So therefore, the answer is 4x plus 3. For example, f of x is equal to 2x plus 1 is to g of x is equal to x minus 2. So f plus g times x is equal to f of x plus g of x. So our f of x is 2x plus 1, then our g of x will be x minus 2. So 2x plus 1 plus x minus 2 is equal to 2x plus x plus 1 times -2.
Rational equation. A rational equation is an equation containing at least one fraction whose the denominator and the numerator are polynomials. So, here's the example.
Over 8 minus 3 over 5 equals x over 10. What do we need to do in order to find the value of x? The best thing we can do is to clear away all fractions we have in 8, 5, and 10. We are going to find the least common denominator or LCD of 8, 5, and 10. Multiples of 5, 10, 15, 20, 25, 30, 35, 40. Multiples of 8, 16, 24, 32, 40. Multiples of 10, 20, 30, 40. So, 40 is the least common denominator. Let's multiply every fraction by 40. So what is 5 over 8 of 40? Divided by 8, which is 5, times 5 on top, and that's gonna be 25. Now, what about 3/5 of 40? It's also the same. 40 divided by 5 is 8. 8 times 3 equals 24. And the last one, 40 divided by 10 is 4, times x That's 4x. 25 minus 24 equals 4x. Subtract 25 and 24. 25 minus 24 equals 1. Copy the 4x, divide both sides by 4. So the answer is 1/4. And so, x is equal to 1/4. So that's the answer.
Inverse function or anti-function is a function that reverses another function. So, here are the examples of inverse function.
f of x is equal to 2x minus 7. What do we need to do? The first thing you do, replace x in y. Y equals 2x minus 7. Now, in this step, switch x with y. So, x is equal to 2y minus 7. And then, after this step, all we need to do is to isolate y into itself. Let's add 7 to the both sides. So, we have x plus 7 equals 2y. Divide both sides by 2. So, x plus 7 over 2 equals y. So, the final answer is the inverse function x equals x plus 7 over 2.
Exponential equation is one in which a variable occurs in the exponent. For example, when both sides of the equation have the same base, the exponent on either side are equal by the property.
Like for example, we have solved for x is to 4 to the power of x equals 32. So in the left side, there is a base of 4. Then there is an exponent with x, which is the unknown. And then in the right side is not an exponential form. So our goal of this problem is we need to convert the 32 as an exponent with base form so that they have a same base. But notice they are not possible because the 32 was not a power of 2. But instead it can be power of 2. So let's try if power of 2. So 2 raised to the 5th power, right? Because 2 to the power of 5th, 2 times 2 times 2 times 2 times 2 equals 32. So, we can represent 4 raised to x equals 2 to the power of 5th. But notice, they are not same base because the left side is 4. Then the right side is 2. But notice, we can apply the equal powers. But as what you have observed, these 4 can convert as an exponent with base 2. So therefore, if we will make it, it will have representation to raise to second power and then we can raise to the power of x. Because this the exponents of applying the graph. Exponent, I think we need to multiply the 2 into the x. So 2 raised to the power of x, but if just an equal here, after that, we need to equate in the 2 to the power of e. So, there is no base. Now equal, so we can now equate their exponent, their base, applying definition on equal power. Therefore, 2x is equal to 5th. So, for x now, divide both sides by 2. Therefore, is equal by 2 5th over 2.
So let's solve the problem. F of x is equals to 1 over x. Immediately, we know that x can't equal 0. So 0 is not part of the domain of this function. Now, what happens as x approaches 0 from either side of x equals 0? negative 1 as negative 1. So, negative 1 and negative 1 is part of the function. As we go left, we are closer and closer to 0 from negative direction with the limit of reaching a 0 as x approaching as negative infinity to the function approaches 0 but never quite gets there when we go left. In this tiny interval from negative 1 into 0, we can see the plug-in In this tiny interval from negative 1 into 0, we can see the plug-in fractions of negative 1 will give us a very big negative numbers, decrease rapidly heading towards negative infinity as x approaches 0, so that will look like this. On the positive side, we can get something similar plugging in 1. We can see that 1 and 1 is part of the function, them with bigger with closer and closer to 0. So that if 1 gives us this behavior approaching to 0, as x gets infinitely large and plugging in of fraction in 1. Bring the function closer and closer to infinity as x approaches on 0.